Hey, this is the first of what I assume to be many videos of me failing to build a powered mountain board. Hopefully you'll be able to learn from my mistakes. So step 1, get a mountain board. I found mine on eBay for 20 quid. If you shop around, you can get a similar sort of price. If you get one new, you're looking at above £100, which is crazy considering you're probably just going to attach a motor to it and smash it up. So, shop around. Step 2, find a motor and ESC. I decided to use this 700 kV, I think it's a 100 amp brushless step motor I had lying around the place, and this 100 amp electronic speed controller. The motor didn't always look like this. This has been modified and recently set on fire. I'll explain why later, don't worry. Depending on your gearing, you can use this, but be careful. I would say either twin it up or get a bigger one, because 100 amps at 24 volts, which I ended up using, although that is phenomenally powerful, 2,400 watts. Although it's a lot of power, that's more than this can actually handle long term. So for a peak it was fine, but a lot of power and this burnt out. But these actually work quite well. I thought this was a bit ropey, a little bit cheap, but it did work relatively well. Step 3, learn how radios and ESCs normally communicate, so you can build the circuit to emulate it, or if you want, just get the radio receiver and transceiver, which I actually did eventually. But I did build a circuit first, which you might want to use, because originally I wanted to control my board using a Scalextric controller, which you can do, and I'll show you how next. I found out that servers communicate using 50 Hz PWM, or pulse width modulation, which essentially means that 50 times a second the servo receives a signal telling it the current throttle position. So I built a circuit using a 16F88 PIC to emulate a servo controller. The code I used to program the PIC is in the doobly what below. I used pin 1 on port A as the ADC input and pin 7 on port B as a PWM output. The code reads the analog value 50 times a second and varies the pulse width accordingly. So this is a really bad light level, I don't know what's happening right now. Step 4! That's 3. Step 4! Build gear housing and attach motor to board. I had about 9 goes at this before I got it even slightly right. My initial attempts used 2 cogs that David found at work, where the tooth ratios are about 2 to 1. But because of the size of the wheel, it would spin when it was free running with no load. So what we have here, the motor in the housing. That's all bolted in place, running through the regulator, and then there is the control circuit. It's just running off a 12 volt supply. Keep powering up my throttle. How cool is that? It worked! But as soon as you apply any load to it, it just wouldn't tap at all. So we had tried to attach sensors to the motor, which is what these little fellas are, if you can see. So I got these off eBay. They were about 20 pence each. They're just Hall effect sensors, and I'll do another video about how they work, because it's quite an interesting science in itself, but they are really interesting. And essentially they detect the motor's position and apply power to the right coil so the motor can get more power. And they work. They give it a lot more torque. They essentially triple the amount of torque you can get out of a brushless motor, which is incredible. But it still didn't have enough power with that gearing ratio, so I stepped it up again and decided to use a chain-driven system using 49 tooth chain wheel, because it's the biggest we could fit inside the wheel housing, and an 11 tooth chain wheel. But again, that had enough power to move it with the sensors, but didn't have enough power to really push you forward, so I decided to fabricate a 6-tooth gear out of stainless steel. Not sure if you can see the smoke, but I am drilling my inner sprocket, so I just need to get a grinder and a polishing disc and tidy it up a little bit. Okay, so I finished making my inner spur. I was going to use David's grinder, but he's not materialised yet today, he's probably got a hangover, so I've done it with a bloody hand file, which took half an hour or so. We have replaced the car battery with some lithium ions, which are more powerful, high voltage too. We're on 24 volts now rather than 12. And as you can see, the tensioner is fully operational. Have you got the controller? Okay, I'm going to elevate it. Just give it some beans. That's not beans. Actually works. Let's go put it on the road. Okay, this is trial run 1 with no payload on the street. success. On? Yeah.
It's problematic just in terms of everything.
Okay, so a couple of problems with the last build. The tensioner was quite flexible and the bars were actually moving, so the chain wheel was becoming a lot less tight, so the chain was slipping off. We also had a couple of problems building the tensioner, but then we decided to build the entire thing out of stainless steel and attach it to the truck using some stainless pipe and some pipe holders, print to the stainless, which had a 45-degree fold in it, which held the chain tightly in place. And essentially we were ready to go at that point. So check out the testing stage of the finished product. Fire! Yes, me shouting fire there was entirely accurate. We did set the motor on fire. I say we, I mainly mean David, because I weigh about 60 kilograms, 55 kilograms, just under 9 stone. He weighs 14 stone, which is what, like 90 kilograms, because he's fat. So essentially, even though we got rid of the car battery, having him on it was the same mass as me and the car battery. So yeah. Anyway, I will make another video soon after I buy a new motor, a bigger motor, possibly a dual drive system, one on each front of the front wheels, with the same chain setup, and see if that's any good. So take it easy, man. I hope you enjoyed this video.